Hi guys, this is the demo for executing the Dask code that we have provided under the DaskDemo folder on GitHub. You would need a couple of things to be set up before you can start it with this. For instance, you would need to install all the libraries that are mentioned in this instructions document. Most importantly, the Dask and the Dask distributed libraries. You can, once you have everything set up, you can open up the IPython notebook and from the DaskDemo from GitHub and start executing the commands right away. But before we do that, let's look at our Dask scheduler. So this is the command to execute to start a Dask scheduler. We can actually set up a pseudo distributed environment on a local machine by opening different threads, one for scheduler and multiple others for workers. So let's try an example of that. So what we do, the way we can invoke the worker threads is by using this command dask worker, and we need to specify the IP address of the scheduler as well as the port number, which is 87886. You can get that from this. So when you execute this command, a new worker thread gets added on gets registered on our scheduler. So we can see this we can see this as an event that gets registered on the Bokeh UI. So the Bokeh provides a web UI which can be used to visualize the status of our scheduler and the Dask distributed environment. So we can see various events occurring in real time. Like for instance, let's see this. In this case, we added a worker, so that appears here as a new event. We can add a new worker thread. In the same way that we can add a new worker thread in the same way that we did before, and we can see in real time that a new worker gets added, and that event gets registered on this dashboard. So let's add one more thread. So yeah, so we have a distributed cluster of 3 workers and 1 scheduler. So let's open the status dashboard, which gives us a real-time UI of that gives us an idea of how the tasks get executed. So this is the DaskDemo IPython notebook from the GitHub link. So you can just run all and get started with this demo right away. So okay, so yeah, the thing that we need to note here is we need to the IP address for the client. The Dask distributor provides a class called client, which we can use to schedule tasks on our scheduler. Schedule tasks on our scheduler. So what we can do is we can create our custom data pipeline by using the dictionary, and then we can specify the IP address of our running scheduler and execute this, and we can see that those tasks get executed here, and we can see them getting executed in real time on the Bokeh UI. So that's a demo of how we can schedule and execute tasks on using the Dask distributed environment. Another thing you might find useful is that we have another library called Dask EC2. So that library is actually providing an entire this Dask EC2 library provides us with a bootstrap loader, and this can be used to set up EC2 instances on AWS on demand. So what we need to do is we need to follow. I mean, we've updated the set of instructions to be followed. You will need to, first of all, you need to have AWS credentials, and you need to, the most important thing is that you will need to set these up as environment variables. So you will need to get an access key and a secret access key from AWS. Another thing is that this EC2 by default sets up this EC2 cluster on the US East 1 region, but that you can change using the region option for this command. So what we will do is let's try to get another thing to note is that this AWS will work only if you have an SSH in your terminal. So that is why we are using the Cygwin terminal for execution. So the first thing, we would also need a key. We'll also need to generate a key pair from AWS. So just show that to you. This is the key pair. This is the EC2 dashboard of AWS. We can go to key pairs, and we can use this create key pair to create a new key pair. So you can give the name of the key pair as anything that you want, and then AWS gives you an option to download the newly generated private key. So you would store that somewhere, like we stored this the private key at this particular location. So for simplicity, we just navigated to that path and we're executing. But ideally, I mean, if you want to execute this command from somewhere else, you would have to specify the path here. So then we can specify the number of EC2 instances that need to be invoked, that needs to be set up. So what this command does is that it would set up the Dask and it would set up Dask and Python and the entire environment on AWS as a distributed cluster of nodes. So let's just execute this command for now. Okay, so this command, this, as you can see, it has already started creating EC2 instances, and these are getting generated. I mean, these are getting created on EC2. These are getting created on AWS. So we would, we'll have to wait for some time for this this command to complete execution, because what this command is doing is it's creating the entire environment, and it's like a bootstrap loader that creates the entire environment on EC2 instances. So we'll pause the video here, and we'll come back to this video when this command has completed execution. Hi, so welcome back. I think this task took about 10-15 minutes to complete execution. So it ran a bunch of shell commands, and it set up the EC2 cluster for us on AWS. We can see that in our EC2 dashboard that 3 instances have been provisioned and are running, and they are in this region, like I mentioned before, US East 1B. The thing to note here is that this Dask EC2 library gives us, after setting up the EC2 instances, it gives us a running Jupyter notebook at this particular URL. So we can copy that. You can see like Jupyter notebook is available at this URL. So we can connect to it by visiting that, and I think the password was Jupyter for this. So we can so basically we have connected to the AWS we have connected to a Jupyter notebook running on an EC2 instance on AWS. So let's check out the address for the web interface. So this is the address for the web interface. So we can just copy this and open on a bokeh UI, so that we get the UI for getting a visual representation of how our tasks execute on the cluster. So let's So now since we have the Jupyter Notebook, it's got a lot of examples as well, and with this NYC taxi database stored on S3, so you can explore this later. But for now, let's do one thing. We'll create a new Python notebook, and let's and what you can do is I have provided this AWS DaskDemo as an IPython notebook in on GitHub. So you can just copy paste all these commands, all these lines of code, all these lines of Python code from AWS DaskDemo into the IPython notebook here, or you can even do an FTP to transfer this notebook to the AWS scheduler, so that you don't have to do the whole part of copy pasting the code. So I'm gonna pause the video here, and I'll come back with I'm gonna copy paste all of this code into the Jupyter notebook over here. So I'm gonna pause the video now for a couple of minutes. Hi, so I have copied the entire code that I have provided to you on GitHub. I have copied that entire code here on the Jupyter notebook, which is running on the EC2 instance on the AWS cluster. So what we can do now is we can start executing some commands to actually connect to the S3 database. I'm sorry, there's this one. This AWS cluster comes inbuilt with all of these files, so you can use them for doing some preliminary, just to try out some of the data science exercises as well on this. So what we're doing is we have built a custom data pipeline in which we load data from the two NYC sets that are present at these paths. Using this command, we do a pandas read CSV to load data from these files into a data frame, and then we calculate the mean for these files. We calculate the means for these the trip distance, and finally we take the sum of the means and store them so we can visualize. This is basically the same kind of pipeline that we built earlier for our local scheduler, just that the files that we're using now are different. They are from the S3 database, S3 file system of AWS. So this is the way we can visualize this our pipeline in this way. And so now when we execute this, we will have to change the IP address of the client, as we've been doing for a local distributed cluster as well. The distributed cluster on a local system. So we were giving the IP address of our local distributor, which was this one. So this one here. But now we would give the IP address of the local of the scheduler, Dask scheduler running on the EC2 instance. So that we can get that from here. So we can get the client. We can get the IP address at which the client needs to connect to. And we can then also see, so we'll try executing this command, and we can see the live we can see the execution of our data pipeline, of our custom data pipeline on the Bokeh UI as we execute it. So we can see a live execution of this as it loads data from different data sets parallelly. So the advantage of AWS is that you can fire up, since your Dask supports distributed computing inherently, we don't really need a different framework for doing all this. Like Dask has all of this inbuilt, and this is a very nice framework to get started immediately on AWS. This is very good for people who wouldn't know how to configure an EC2 instance manually and set up all of this data on. I mean, set up this entire environment on the EC2 instance. So this is a very good way to start doing work right away. Like you can just execute a command and all your EC2 instances can get provisioned. So this data that we are loading is quite huge, and in fact you can even set up like a lot of clusters and have you can load data from multiple workers can load data in parallel and maybe perform calculations faster than doing everything on a local file, locally. Than performing all these tasks on a single machine. So this is how this is Dask, and you can so this is how you can use this entire demo that we have provided on GitHub. And if you have any questions, please feel free to email me. Please feel free to email us. This task has completed. As we can see, it has calculated the mean, and we can shut down that client. And so that's it. That's it with the demo and how we can execute these files. So thank you.